The day 13 of Advent of Cyber. Let's dive into the storyline of today and see what's happening in the city of Weville before we get our hands dirty with Yara and Yara rules. Let's diving into the story. When Mix Kitty went missing, there was chaos and uncertainty at the Best Festival Company. However, even in her disappearance, Mix Kitty was trying to help the Best Festival Company Blue Team, taking a page out of the crisis communication process. MixKitty sent what looks like a bunch of images to the blue team from an anonymous location. These images look like they were related to Easter preparations, but they contain a message sent by MixKitty. The crisis communication process outlines that a message might be sent through a folder of images containing hidden messages that can be decoded if you know the keyword. The blue team has to create a YARA rule that runs on the directory containing the images. The YARA rule must trigger a keyword followed by a code word. After extracting all the code words in the ascending order, the blue team will be able to decode the message. Oh, that's our objective of today. But what are the learning objectives of today? It is to understand the basic concept of YARA, learn when and why we need to use YARA rules, explore different types of YARA rules, learn how to write YARA rules, and practically detect malicious indicators using YARA. Connecting to the machine today, so we have to start a machine, and we have a split screen available to us for today's machine. So starting those things, let's click on the check. It also says message here. It says in the this streak has bothering. In the attached VM, the folder sent by MixKitty has been downloaded to the Ubuntu downloads Easter. Okay, that's the folder. We will be using this folder to run the YARA rules against. Okay, they have given us the information about where the rules are going to be running. Now, for a moment, let's push this to the side so that we can continue reading through the storyline and tasks of today. When we need to get into hands on, we can push that further. Yara overview. At this stage, Mix Kitty, the lead defender, has entrusted you with a mission involving the use of Yara rules. Before jumping into action, let us take a closer look at what Yara is, how it works, and why it's such a valuable tool in the best festival companies' fight to protect SOC mass. Yara is a tool built to identify and classify malware by searching for unique patterns, the digital footprints left behind by attackers. Imagine it's a detective's notebook for cyber defenders. Instead of destructing for prints, Yara scans code, files, and memory for subtle tracks that reveals a threat's identity. Within the Best Festival company, Yara serves as a silent guardian, scanning through the systems and uncover faintest traces of malicious activity that others might overlook. Now, as snow drifts over Weville and Sokma's network trembles under threat, it's your turn to wield these tools and restore the balance. Why Yara matters and when to use it. You might wonder when MixKitty chose this tool for the mission. In the world of cyber attacks, the defenders face an endless stream of alerts, suspicious files, and anomalies network fragments. Not every threat stands out. Some hide in plain sight, disguised as harmless document or script. That's where Yara shines. Yara gives defenders the power to detect malware by its behavior and patterns, not just by name. Yara allows you to define your own rules, providing your own view of what constitute malicious behavior. And you're not alone. Many Yara rules have already been written by defenders from other kingdoms that once faced similar threats. You can use, adapt, and improve these shared rules to strengthen the best festive company's defense and protect SOC mass together. For the defenders of the SOC mass, this means fast detection, smarter hunts, and fewer threats slipping by unseen. In what situations might defenders rely on this tool? Post-incident analysis. When security team needs to verify whether traces of malware found on one compromised host still exist elsewhere in the environment. Other cases are threat hunting, searching through systems and endpoint for signs of known or related malware families. Intelligence-based scans, applying shared YARA rules from other defenders or kingdoms to detect new indicators of compromise. Memory analysis, examining active process in a memory dump for malicious code fragments. These examples above show common use of YARA, but defenders often find even more creative ways to apply it during investigations and hunts. YARA values. In the constant battle of to protect Sokmas, time and precision matters most. That's where YARA shows its true value. It gives defenders clarity in chaos. With YARA, you're not waiting for an antivirus update or third party alert. You have the power to create your own rules, detect new variants, and act before the threat spreads. For the best festive companies defenders, YARA brings several key advantages. Speed quickly scans a large set of files or systems to identify suspicious ones. Flexibility detects everything from text strings to binary patterns and complex logic. Control lets analysts define exactly what they consider malicious. Shareability rules can be reused to improved by other defenders across kingdoms. Basically, even other researchers or other defenders. That's what they are meaning by defenders across kingdoms. Visibility helps connect scattered clues into a clear picture of attack. In short, Yara empowers defenders to move from passive monitoring to active hunting, tunneling intelligence into action before attackers strike again. Getting into Yara rules. Now that you mentioned what Yara is and when it to use it, it's time to see how it actually works. To uncover the digital footprints of the evil King Malhare, a YARA rule is built from several key elements. Metadata, information about the rule itself, who created it, when, and for what purpose. Strings, the clues YARA searches for, text, byte sequence, or regular expression that marks suspicious content. Conditions, the logic that decides when the rule triggers, combining multiple strings or parameters into a single detection. Here's how it looks in practice. So they've given us an example of a YARA rule. It's a snippet of a YARA rule that is presented to us. It says, rule the best festive company King Malhare trace. So it's trying to trace for anything like that. It's the name which is assigned to this YARA rule. And the metadata consists of the author, that is who is writing, defender of SOC mass. It could be even of your organization saying the SOC team. So the author can be there. Then the description, why are we writing this YARA rule, which is to detect traces of King Malhare's malware, and the date. Now, these metadatas are a little dynamic. If you want, you can add them. If not, you can even leave it some blank spaces. That's not an issue with the metadata. That's moving to the next. It says strings. Now, what and all do we actually want to find? Such as one string is declared as rundle ll32.exe, full word in ASCII, and another string is mentioned as one more file. It says again full word and wide. They are basically another type of character sequences which can be used. Then other says URL1, which has anything as a HTTP / malhar, anything with the word malhar in between, and no case, like no case sensitive situation is there. Then condition, any of them. So you find any of these things that is present, it's going to trigger this rule. In this example, you can see that the meta section contains fields like the author, description, and date. These fields are not required, but they are highly recommended. They help you and other defenders understand what the rule is about, who created it, and when it was written. When your collection of YARA rules grow, having clear metadata will save you time. Without it, finding or updating the right rule can be quickly becoming a challenge. Next, we see the strings section. This is where you define the actual clues, text, byte sequences, or regular expression that the YARA should search for. Finally, the condition selection tells YARA when to flag a match based on the logic you define, in our case, any of the strings. Together, these three parts form the foundation of every YARA rule. Let's take a closer look at the strings and conditions to understand how they work in practice. Strings. As mentioned earlier, strings are the clues that YARA searches when scanning files, memory, or other data sources. They represent the signature of malicious activity in fragments of text, bytes, or patterns that can reveal the process of King Malhare's code. In YARA, there are three main types of strings, each with its own purpose. Let's talk about them and see how they can help defend the kingdom of the best festival company. Text strings. Text strings are the simplest and the most common type used in YARA rules. They represent words or short text fragments that might appear in a file, script, or memory. By default, YARA treats text strings as ASCII and case sensitive, but you can modify how they behave using special modifiers, small keywords added after the string definition. The example below shows a simple rule that searches for the word Christmas inside a file. So there's another YARA rule. It talks about the best festive company King Malhare trace, and the string is defined with the string Christmas, and the condition is the same thing if it is able to verify it or not. Sometimes attackers like King Malhar try to hide their code by changing how text look inside a file, using encoding, case tricks, or even encryption. Yara helps defenders counter these obfuscation methods with a few powerful modifiers that extend the capabilities of text strings, which is case insensitive string no case. By default, Yara matches text exactly as written. Adding the no case modifier makes the match ignore the letter casing. So, Christmas, or Christmas will all trigger the same results. They have given also the example of it, which is no case. And with this, we have multiple combinations of Christmas. It will still identify it, irrespective of which letter or which character is having a different case in the sequence. Also, wide character string wild ASCII. Many Windows executables use 2-bit Unicode characters. Adding wide tells Yara to also look for this format. While ASCII enforces a single bit search, you can use both together. So they've given an example of Xmas, Christmas, wide, and ASCII. Now, we could actually decode this using some decompilers and see how Windows executes it, but let's not get into it. But that's what they're talking about. When it's present inside the Windows executable formats, you might find it in either the ASCII format, which is the normal English letters that we see in, or the 2-bit versions of it, like the wide, which is also another format of how the Windows processes the executable files. XOR strings or XOR. Malha's agents often XOR encode text to hide it from scanners. Using XOR modifier, Yara automatically checks all possible single byte XOR variations of a string, revealing what attackers tried to conceal. Strings hidden Malhar XOR. So it's going to use the XOR formula of hiding in something which is present inside a string format. Now, when you do XOR with a key, it's going to be able to decode it back to it. So it's also going to have those algorithms built into it, which can even identify XOR encryptions present inside any executable file or a hidden folder. Base 64 strings, base 64 wide. Some malware encoders payloads or commands in base 64. With these modifiers, Yara decodes the content and searches for the original pattern, even when it's hidden in the encoded form. And they've given the example. It's going to decode the sock mass into a base 64 encoded. Sorry, there is a base 64 encoded text. It's going to decode it and identify if it matches to the sock mass as a string, which is passed there. Each of these modifiers make your rule smarter and more resilient, ensuring that even when King Malhar disgraces his code, defenders of the best festive company can still uncover the truth. Hexadecimal strings. Sometimes King Malhar's code doesn't leave readable words behind. Instead, it hides in raw bytes deep inside executables or memory. That's when hexadecimal strings come to the rescue. Hex strings allow Yara to search for specific byte patterns written in hexadecimal notation. This is useful when defenders need to detect malware fragments like the file headers, shellcodes, or binary signatures that can't be represented as a plain text. They have given an example of another Yara rule which talks about the string containing a hexadecimal character, which is a header of Windows executable, MZ header of a Windows executable. Then the hexa string is also passed in here. Then the condition is for to compare these two things if it is present or not. Now the regular expression strings. Not all traces of King Malhar's malware follow a fixed pattern. Sometimes his codes mutates small changes in file names, URLs, or commands to make it harder to detect using plain text or hex strings. That's where regular expressions come in. Regex allows defenders to write flexible search patterns that can match multiple variations of the same malicious string. It's especially useful for spotting URLs, encoded commands, or file names that share a structure but differ slightly each time. And they're sharing another example of this thing. Now, they're passing a URL with some special characters to it, and they've given a no case as a parameter to check. Also, here a PowerShell and with other regular expressions also being present from A to Z and A to Z in both the case sensitives, and 0 to 9 as the digits present there. So, all these regular expressions can also be passed in to check for any specific patterns in shell codes or URLs or some other variations where it requires some regular expression matches. Regex strings are powerful but should be used carefully. They can match a wide range of data and may slow down scans if written too broadly. Conditions. Now that the defenders of the best festival company know how to describe what to look for using strings, it's time to learn when YARA should decide that a threat has been found. That logic lives inside the conditions section, the heart of every YARA rule. The condition tells YARA when the rule should trigger based on the results of all the string checks. Think of it as the final decision point, the moment when the system confirms, yes, this looks like King Malhare's code. Let's look at a few basic example defenders use in their daily missions. Match a single string. The simplest condition, the rule triggers if one specific string is found. For example, variable x must match any string. When multiple strings are defined, the rule can be configured to trigger as soon as any one of them is found. Any one of them is another condition. This approach is useful for detecting early signs of compromise. Even a single matching clue can be enough to raise attention. Match all strings. To make the rule stricter, you can require all the defined strings appear together. So until unless all of the strings which is defined comes in, it's not going to flag them. This approach reduces false positive. YARA will only flag the files in every indicator matches. Combine logic using and or not. Defenders often need more control over how rules behave. Logical operations let you combine multiple checks into one condition, just like building a small defensive strategy. Condition either the string 1 or the string 2 and not the string begin. So it's like combining, tell me either this or this, and which doesn't have this. So that's using all the three operators there. This means the rule will trigger if either string 1 or string 2 is found, but not begin. In other words, detect suspicious code but ignore harmless system files. Use comparisons like file size, entry point, or hash. YARA can also check if file properties, not just contents. For example, if you detect files that are unusually small or large, a common trick used by King Malhare to disguise his payloads. Condition any of them and which is file size less than 700 KB. Here, the rule will trigger only when one of the string matches and the file size is smaller than 700 kilobytes. Now that you have reviewed the main examples of conditions, now it's time to move on to the practical use case when these rules come to life. YARA study use cases. The evil kingdom of Malhai used a Trojan known as ICE ID to steal credentials from the system. Mixkitty's analysts discovered that the malicious file spread across Wereville shared a common signature, the MZ header found in the executable malware used by the Dark Kingdom. These samples were small, lightweight loaders designed to infiltrate systems and later summon more dangerous payloads. Let's write your YARA rule. So they've given the YARA rule for detecting the MZ headers in a Windows system. Meta, which is the author who is writing it, the description, this is to say ICE ID rule, then the date when they are writing it, then the confidence of this. Now, confidence is something like how are you positive about the rule detecting these files, or it can mean anything. It could just mean anything that you want to the if you want to later identify what's happening in this, to identify a keyword they have given as confidence is equal to low. Then the string that they actually want to see is the MZ, basically the MZ header of a PE file. It's nothing but portable executable file. Then hexadecimal, passing in the malicious binary fragments, the fragments which they earlier collected from other systems to see if this hexadecimal characters, maybe like the headers of any file, is present there. Or the string one, Malhare no case, means that anything which has the word Malhare with any case sensitive content, it can just check for it. Then conditions all of them, and file size which is less than some number which is 10 MB in size. So anything which is less than 10 megabytes of size, and all of these strings should match. Or unless save this to a file named iceid starter.yara and executed it on one of the hosts. As a result, we can see that one file was detected. Yara r iceid starter.yara and then run it against the C drive. Iceid starter, and it has identified that Malhare gift loader.exe was containing these conditions, which is it had a MZ header, it has the malicious binary fragment, and it also had the keyword called as Malhare somewhere in this file, which means that this has been flagged by the YARA rule by matching all of them which is present in it. We can use the man YARA command to find out what the flag could be useful in our scenario, and we find the following. -R allows the YARA to scan directories recursively and follow system links. Yes prints the string found within the file that matches the rule. And we can see that Malhare is also present in the file name. Putting everything together, this YARA command recursively scans the C drive using the iceid starter.yara rule file and can optionally display the matching strings when using S as the parameter there, or the option there. Next up, it is an interesting task where you will need to create your own YARA rule. Good luck. Oh, we are supposed to do it. Okay, it's time to complete the practical task. The blue team has to search for a keyword, the best festive company, followed by an ASCII alphanumeric keyword across the home Ubuntu downloads Easter directory to extract the message sent by Mixkitty. Can you help decode the message sent by the Mixkitty? Okay, so let's bring up our screen here, make it quite bigger. And are you in any plan of changing the location where you show up this? Okay, that's good. That is going to be helpful for us. That's the only thing. Come on, can't you just go there? Let me try it once again. Let me resize this little big. Hopefully this much. Yeah, this is enough for me. Now let's open this, and what we'll do is let's go to the directory that they have mentioned us to go. So cd to the downloads, then to the Easter, GOWN was okay, cd downloads. I'm sorry with that. Downloads, then to the Easter. Here we have so many files here, and we have some of the file called as embeds. What is that file called as? I mean, what does that do? File embeds. It's an ASCII file, which means that I can look at what it is doing. It says import global random speed 42. Find me in Hopsec Island. Phrase split. Okay, maybe something related to where we need to find. The anything which is there? What is the message sent by Mixkitty? Find me in Hopsec. I guess we have found it here in the embeds file. Okay, we are supposed to find it through the YARA file, I guess. That's what is the challenge here. It says it's time to complete the practical task. The blue team has to search for the keyword, the best festive company. I guess that's also present here, followed by ASCII alphanumeric keywords. Okay, let's write a YARA rule. So let's use nano editor for this. I'll put it up here. It says nano. Let's call it as Mixkitty itself, mcskidy dot yar. Pressing enter. Now we are into a nano editor. So I'll copy the existing code here such that we can just paste it there. And like, okay, I'm able to edit there. So let's open this, replace the clipboard with, not that one. Let's copy this, paste it there, then remove all these garbage, replace it with this. Now let's call this rule to be as mix kitty rule, right? Or let's call it as find underscore mix skidy mix kitty. So the metadata author. So do we have a name? I don't think so. We have a name. So let's call it as the blue team. Then our description is finding mix kitty. Finding mix kitty and her location. Okay. Then the date is the 13th of um or the 12th month and the 13th date. Then confidence, we are high in confidence of finding her. So let's write as high. Then now the string section, we don't want all these parameters there. So let's remove them. Not the tab button, sorry. Delete here. Let's remove all these things. Let's only keep S1 there, right? That would have done it. Okay, let's write it here once again. S1 is equal to, and then Malhare. Instead of Malhare, let's remove all these contents and call it as what was that? TBFC slash and then all the regular expression patterns. For that, they've also given us the content right above here with the PowerShell here. It is A to Z and A to Z again with the lowercase sensitive. So let's add in that parameter also here. We'll call that as from A to Z, then A to Z, then 0 to 9 plus slash equal to and close it with this. I guess this should do it. That will start to give us some contents about any content which is there after the TBFC with some regular alphanumeric expressions also there. That's what they have asked us, followed by an ASCII alphanumeric keywords across that. So yeah, this will do it. Then let's also change the condition. Let's say all of them itself, or we can even say S1, which will mean the same. Let's remove all these extra contents which is there and just write it as $S1. With that, I guess we can press Ctrl X, Y, and enter. Let's try running this file. There could be some errors in it, so we can debug it later. So YARA and -r, we are passing in the file. -s would also say which file it is. Then mixkitty.yar, then the file that we want to actually scan for. So we can either give a dot, which is say the present working directory, but at the same time we can also pass in the entire direct location where we want to see it. So copy, put it here, then pasting it here, pressing enter. This should look correct. So invalid regular expression S1 missing, terminating this for the character class. Okay, with a little bit of debugging here, I noticed and found out that we need to add a forward or backslash to that such that it doesn't get interrupted there. And now if I click on Ctrl X, Y and enter and now run the code, hopefully this is going to work fine. Okay, this did. Finally, I'm happy that it did. Now, find mixed kitty home gave us that it is found in Easter 46, Easter 16, Easter 10, and Easter 52, and Easter 25. And it says, this is what? Hop, sec, me, find, island, in. So it has all these different words randomly present in it. I guess using the numbers, we can identify which file it is. But now let's answer some of these questions. How many images contain the string TBFC. 1, 2, 3, 4, 5. So it has 5 in it. Click on check. That's right. What regex would you use to match a string that begins with TBFC followed by one or more alphanumeric ASCII characters? Let's print out the contents that we have in mixkitty.yara and pass in this content. I guess only this much is enough. So let's copy it from the clipboard. Cancel. Let's copy this and paste it there. Checking, loading. Oh no, the answer you Okay, I guess what we need to do is we need to remove these special characters which we specifically added. I guess they are asking for TBFC colon, then bracket A to Z, then A to Z once again, then 0 to 9, then close it with this plus, and yeah, that is right. So that is basically they're removing out all the other contents we have just added. This is also one of the way of representing that. What is the message sent by mixed kitty? We actually know that it is like find me. So it says find me in hop sec island. I missed out D there. Okay, it worked fine. With that, we have finished the day 13 of Advent of Cyber. Now, this was a bit of tricky because YARA rules and the tools between running them have a little bit of syntax issues, but that's fine. But with that, we have finished the day 13 of Advent of Cyber. It was exciting to create some YARA rules and figure out the contents that is present inside them. Also, I just wanted to see this and show this that okay, whatever this is, let's click on continue, close. We could also use the strings command for this. Now, the purpose of YARA is such that we can scan the entire system. Strings, we can't exactly go for each of the files and look at it. Let's take an example of Easter 25 here. If you filter out the contents, which is called as strings, we can see that we find TBFC present in it, which also means that if I can grep it right, just show me the contents. What was there? No, let's run the YARA rules once again so that we can see the contents that we found from Easter 25. What we can do here is run this once again, and with the strings, and then I'll grep for it says in here, right? TBFC in. We can just grep for TBFC and then see that we find in it. Now we can also do this for 52. So I can pass in 52 and I can see island to be present there after the TBFC. So it's somewhat doing like that with the regular expression. It's trying to see if after it finds out the TBFC, what is present in that line. And we are able to identify it. We can also look at 16 to do see what's present inside that file. It's me there. Now, if I just print out the contents which is present in Easter 16.jpg, it is whole bunch of things which we cannot understand, or we can understand if you are not a human. And so yeah, these are the contents which is present in the image. Now, out of this image, what are the strings which is read as an ASCII character is what is identified here. So Easter 16.jpg, and we can see these are all the ASCII characters containing some language which we can see. Yeah, so that's what is another method, which if you have a single file, that's how you can look at the strings and identify contents out of it. Okay, with that, we have finished the day 13 of Advent of Cyber. Meet you all in the day 14 of Advent of Cyber. Till then, stay happy, stay smiling. Thank you for watching. Meet you all on the day 14th of Advent of Cyber. Thank you for watching. Bye bye.